Hello everyone. Today we can talk about how does process megahertz relate to end user performance. Uh, this also relates to memory subsystem and instruction set too. Uh, Coming to introduction to processor megahertz and performance. Processor megahertz indicates the clock speed which measures how many cycles a CPU can execute per second. Higher megahertz generally suggests a faster processor, but it doesn't always translate directly to a better user experience. Other factors like memory, instruction set, and architecture also significantly impact end user performance. So this processor megahertz MHz, which directly refers to megahertz, indicates the clock speed, like how much faster how many cycles the CPU is running, can execute per second. It may not directly be how many cycles it can run, which will which will be determined by the task we are running, but it is the theoretical value with like how many cycles execute per second. Higher megahertz may suggest a faster processor, but doesn't always translate to a better user experience because even if it's very fast, if it's not up to our usage standards, it may not lead us to a better user experience. There are also other factors like memory, instruction set, and architecture, which will significantly impact the end user performance which we have. Coming to understanding processor megahertz refers to the clock speed typically measured in millions of cycles per second. It influences how quickly a processor can process instructions within a given time frame. However, megahertz alone doesn't account for efficiency of overall capability of the processor. So this processor megahertz refers to the clock speed, as I said previously itself, which can go up to millions of cycles per second. It is also influence how a processor can uh, process the instructions given to it within a given time frame, like how much time it is confused to process the instructions given to it in a time frame. However, this doesn't account for the efficiency or overall capability of the processor itself. Well, coming to the relationship between the megahertz and the performance, a higher megahertz can lead to faster data processing, reducing wait times for the user. Nonetheless, nonetheless, performance depends how effectively the processor executes the instructions in each cycle. Modern processors often run at lower megahertz but compensate with advanced architectures and multiple cores. A higher megahertz can lead to faster processing. It can also reduce wait times for the user itself. Nonetheless, the performance is dependent on how efficiently the processor is doing the process at each cycle. Like if even if it's having a higher megahertz and having higher clock cycles, if it's not effectively utilized, the process is not effectively executing and utilizing instructions at every cycle, the performance will not be up to the mark. And also more modern coming to the modern mega processors, it is also run at lower megahertz but compensate with advanced architectures by having multiple cores, and also they process everything accurately, and also execute the instructions properly at each cycle. Coming to limitations of using megahertz as a performance metric. Megahertz doesn't reflect improvements in architecture, such as instruction pipelining or parallel execution. It ignores efficiency of instruction set and how well the processor utilizes its resources. Relying solely on megahertz can be misleading when comparing different processors and real world performance. So this megahertz this doesn't it is not related to improvements in architecture. It's instruction pipelining or parallel execution. This megahertz directly ignores the efficiency of instruction sets and how well the processor utilizes resources is not definitely not at all related to it. So relying solely on this megahertz can be misleading when comparing different processors in real-time usage and real-time performance. Comparing to the memory subsystem role in performance. The memory subsystem includes RAM, cache, and storage, which work together to supply data to the processor. Faster memory and larger caches reduce data access delays, improving overall system responsiveness. A weak memory subsystem can bottleneck performance even with a high megahertz processor. So this is where this starts. The memory subsystem, which may plays another great role in performance. This includes RAM, cache, and storage, which they all gather together to separate it to the processor where the processing is done. But if as these are not up to the mark, the memory system is not up to the mark, relatively not enough data cannot be passed over to the processor, which will reduce the amount of task being done at a singular time. This also does not being able to utilize the full power of the processor at the time. So faster memory and larger caches reduce data access delays, improving overall system responsiveness. So if there is a faster memory and larger cache, uh, which depends on the memory subsystem, it will improve the delay of the system data access delay, like the data to flowing going from this RAM cache and storage to the processor, which will the delay will be lowered, and which also increases the system's overall responsiveness. A weak memory subsystem can bottleneck performance even with a high processor. So both of the parts, even if you have a high processor and a low memory subsystem, performance will bottleneck. If even if both are, it will easily outpace the high processor one and low processor memory subsystem one, even if the both memory subsystem and the megahertz processor are mid-range. Well, coming to instruction set and its impact on performance. The instruction set defines the basic operations a processor can perform, including efficiency, more optimized or complex instructions can execute tasks faster or more efficiently. Uh, Compatibility and support for advanced instructions can improve performance of specific applications. So this instruction set, it defines the basic operations of the processor can perform, including the efficiency. So the more optimized or more complex an instruction set, it can execute tasks faster and more efficient. So compatibility and support for advanced instructions can improve performance for specific applications. Uh, if there is enough compatibility and support for these advanced instructions, performance can easily thoroughly be improved for any type of specific application. How memory and instruction set interact with the megahertz. The effectiveness of a high megahertz processor depends on the memory subsystems availability to keep it fed up with data. An efficient instruction set complements high megahertz by executing instructions rapidly and effectively. Together, these components determine how well a system performs from an end user experience. The effectiveness of high megahertz processor, this usually depends on the memory subsystem earlier. As I said in the memory subsystem part in the previously, if memory subsystem is not up to the par of the processor, a bottleneck will form, not allowing the data to flow smoothly, which will result in less processing of data. If an efficient instruction set, which will complementing this by this megahertz, which can execute these instructions rapidly and effectively. If an efficient instruction set is placed in the high megahertz place, uh, execution becomes easy. So they'll be more accurate and they'll be more effective and be more faster too. Together, all these components, this will determine how well a system performs from the real user experience which we have. Real world performance considerations. End user performance is a combination of processor speed, memory access speed, and instructions execution efficiency. Tasks like gaming, video editing, and multitasking benefit from balanced upgrades across all components. Upgrading only the megahertz can lead to limited performance gains without corresponding improvements elsewhere. As I said earlier, all components should be, even if mediumly balanced, can outpace easily a singly highly advanced processor or a uh, if there is a build with a mid-range components all over and there is another build with a singular high-range component or low-range components, easily the mid-range one easily one due to the not having any bottlenecks and also data being flowed smoothly over the memory subsystem and the uh, processor megahertz itself. So this heavily changes the game of the end user experience, because uh, we do not care about the processor, etc. We only care about how our end user experience is. So we should tasks like gaming, video editing, multitasking, which we heavily require which are very highly intensive tasks, resource intensive tasks, require all balancer components. Coming to next, summary of processor megahertz memory and instruction set. Processor megahertz provides a baseline measure of potential speed, but it isn't the sole indicator of performance. The memory subsystem and instruction set significantly influence how effectively processor speed translates to user experience. A holistic approach to system upgrades ensures better end user performance than solely focusing on megahertz. Processor megahertz, it is a baseline measure for the potential speed which we have, but it isn't the sole indicator of performance. Like we cannot depend on processor megahertz to derive the performance of the system itself. There are many factors which determine the performance, speed of performance, and processor megahertz it just plays a part in it, but it's not the uh, not the final figure of the potential speed of this system. The memory subsystem and instruction set significantly influence how can the speed of the process speed can be enhanced in our user experience. Like how can can get a better user experience depends on how the memory subsystem is and the instruction set. How is the instruction set? Uh, which will directly correlate to the user experience. A good approach to system upgrades ensures better end user performance than solely focus megahertz. So this system upgrades optimize our PC to better handle the instruction sets and memory subsystems, and utilize them with the processor megahertz, which will better provide a better user experience than solely focusing on megahertz. Coming to conclusion and best practices, when evaluating performance, considering both processor megahertz and quality of memory subsystem and instruction set, optimizing all components leads to noticeable improvement in end user performance and responsiveness. Understanding these relationships helps users and professionals make informed decisions about hardware upgrades. When we evaluate performance, we should consider both performance and quality of memory subsystem and instruction set. Should not take both only the megas processor megahertz or if only the memory subsystem itself. We should consider all things equally. Though even then only we can get a proper end user experience. By optimizing all these components can lead a noticeable improvement in the end user experience and also improves in performance and responsiveness. Uh, by understanding the relationships between all these systems, we can this can help us users and also professionals make informed decisions about these hardware upgrades or software which we need in the future to improve our performance even more if we want to. Uh, well, thank you for listening to the presentation.